Design engineers often worry about which metal processing process is suitable for the workpiece at hand. We will introduce 5 common metal parts manufacturing processes in this video. 5 common metal parts manufacturing processes include investment casting, machining, die casting, powder metallurgy, and metal injection molding. The first is investment casting. Investment casting is the process of making wax molds, which are then melted and filled with metal to create metal parts. A wax mold of the same shape as the final metal part is created, which is then painted or impregnated in multiple layers to form a solid shell. The wax mold is heated so that the wax in it melts and flows out, resulting in a shell with a hollow interior. The high-temperature metal is poured into the interior space of the shell and fully fills all crevices and voids. Wait for the metal to cool in cooling water until fully solidified and hard. The shell can then be broken to finally obtain the cast workpiece. Since investment casting uses high-temperature metal to pour into the mold, the shape of the workpiece made by this process is relatively simple and the thickness of the workpiece needs to be more than 2 mm. The cost of casting workpieces is considered medium among these 5 processes. The density of casting workpieces is made of molten metal, so the relative density can reach more than 99%. The surface of the cast workpiece often has sandholes, so the surface roughness can only be plated to about 5 micrometer, and surface can be electroplated. The second process is machining. CNC machining is more common in mechanical processing, which uses computer-controlled machines to process metals, such as grinding and drilling. Higher accuracy can be achieved as using higher level of CNC machine. The dimensional accuracy of the workpiece obtained by CNC machining is the highest among these 5 processes, and the mechanical strength and relative density are also the same as the raw material. However, the slow speed of CNC processing increases the production cost, so this process is not suitable for mass production, such as 3C products. The third processing method is die casting. Die casting is a manufacturing process used to produce metal parts by injecting molten metal, such as aluminum or zinc, under high pressure into a steel mold called a die. The metal solidifies quickly, forming the desired shape of the part, which is then ejected from the die. This process is highly efficient and can produce parts with complex shapes, fine details, and tight tolerances. Die casting uses injection technology, so the production capacity is very high, but the material is limited to use only low-temperature metals such as zinc alloy or aluminum alloy, so the mechanical strength and hardness of the workpiece are relatively low. For example, the hardness of the commonly used zinc alloy is HB100, and the medium carbon steel after heat treatment can reach more than HB400, so the die casting workpiece is not suitable for structural parts, such as wear resistance requirements. Next, we will explain the process of powder metallurgy. Powder metallurgy is different from the above-mentioned process. Molten metal is shaped by the mold. Instead, the metal is first melted and then sprayed to obtain metal powders, and there are many types of metal powders that can be made, such as iron powders, stainless steel powders, copper powders, tungsten powders, etc. Metal powder is used as the raw material, and then molding machine is used to obtain green parts. The PM molding machine is similar to one of stamping process, and the cycle time is about 4 to 7 seconds. After the green parts are sintered at high temperature, final metal products can be obtained. This method of using metal powders as a raw material to make metal parts is called powder metallurgy. Powder metallurgy is currently making metal parts, which can be simply divided into traditional powder metallurgy and metal injection molding. The major difference between these two is in forming process. MIM can make 3D shapes with an injection machine, and PM can only produce 2.5D shapes with press machine. Besides, the powders used are also different. We will introduce PM process in detail in another video. For material strength, the mechanical properties of MIM parts are almost the same as those of machined materials, which are quite different from traditional powder metallurgy. Therefore, in recent years, metal injection molding has been more and more widely used in 3C and automotive components. If you need more information about HPM, please go to UPT website or FB. Thank you.